Hi, today on Trigonometry, we're going to compute a limit using the limit laws. The limit that we're going to compute is this one. The limit as x goes to 3 of the quantity x squared minus x minus 6 divided by the quantity x cubed minus 9x. Now typically everybody's first thought on computing a limit is to just plug in the value that x is going to. Now if the function that you're taking the limit of is continuous at the point that x is going to, then you can plug it in. In fact, that's actually what continuity means. But in this situation here, you can see that this function is actually not defined at x equals 3 because it'll make the denominator equal to 0. In fact, if you tried to plug in x equals 3 for every value of x here, you'd get this. 3 squared minus 3 minus 6 all over the quantity 3 cubed minus 9 times 3. Well, on the denominator, you can see that it becomes 27 minus 27, and you get a 0 in the denominator while also getting a 0 on the numerator. So this will produce a 0 over 0 kind of situation, which is undefined, and certainly shows that we cannot compute the limit this way. So before we can start using the limit laws, what we have to do is simplify this equation a little bit. To do that, let's factor both the numerator and the denominator. The numerator factors as x minus 3 times x plus 2. If you need a review on how to factor a trinomial, I have a great trigonometry video that shows you how to factor trinomials without having to guess any factors, and you can find a link for that in the description. The bottom factors as x times, and you'll get an x squared minus 9 here left over, but that term factors as x plus 3 times x minus 3 to yield x times x plus 3 times x minus 3. At this point, you can see that there is an x minus 3 factor in both the top and the bottom. Now we're trying to compute a limit of this function. The limit is asking what is the intention of the function or the behavior of the function as x goes close to 3 or moves towards 3. It's not asking about the behavior of the function at 3. And everywhere other than x equals 3, this x minus 3 will be a non-zero value that we can cancel from this fraction. And so where this function with the x minus 3 factors in the top and the bottom goes to as x goes to 3 is the same place that the function without the x minus 3's will go to as x goes to 3. And so this becomes the limit as x goes to 3 of x plus 2 over the quantity x times x plus 3. Now for this function here, it does turn out that this rational function is defined at x equals 3. Now that we have a scenario where we're not going to get a 0 over 0 anymore, we can use the limit laws to resolve this limit. For a rational function that's defined at the place that you're taking the limit towards, you're able to take the limit and apply it to both the numerator and the denominator. This will turn into the limit as x goes to 3 of the numerator divided by the limit as x goes to 3 of the denominator. Now on the numerator, you just have a polynomial, which allows us to spread the limit out across those pieces. And you'd end up with the limit as x goes to 3 of x plus the limit as x goes to 3 of 2. On the denominator, we have a product, and the limit distributes across that product as well to give us the limit as x goes to 3 of x times the limit as x goes to 3 of the quantity x plus 3. The second term in the denominator is again a polynomial, and so that'll distribute once more, which will give us on the bottom the limit as x goes to 3 of x times the quantity, the limit as x goes to 3 of x, plus the limit as x goes to 3 of 3. Now in each of these cases here, we have a limit as x goes to 3 of some power of x, or the limit as x goes to 3 of some number. In each of those cases, we can use the limit laws again to indicate that the numbers will just stay the same, and the x's will just plug in the value that x is going towards. And so this yields the quantity 3 plus 2 all over the quantity 3 times the quantity 3 plus 3. Now, if you notice, this is exactly what we got by plugging in 3 to the rational function after we canceled out the problem factor of x minus 3. And indeed, that's true. For rational functions where you're taking a limit as x approaches a value that's in the domain of that rational function, you can compute the limit by just plugging in for x the value of where x is going towards. So in this case, we could have just plugged in 3 at this earlier step into the rational function and arrived at this 3 plus 2 over 3 times 3 plus 3, which of course yields 5/18. And that's how you compute a limit using the limit laws. If you want more practice with computing limits, check out some of my other example videos on this topic. We'll see you next time on Trigonometry.